See going across the country of Russia. It doesn't look like a country because it's split up into its different time zones. In the nautical world, we always talk of time zones to the east as being UT minus and time zones to the west. That the moon is moving away from the Earth is equal to the speed that your fingernails grow at. But it does open up the questions of when do you change your clocks at sea, what about your watch systems, etc. The data for secondary port time differences is given for the almanac time of that port.
Hey everybody, Stuart from Ardent Training here again, and tonight on our webinar I'm going to talk to you about time. So I'm actually currently in New Zealand at the moment, which puts me on a very different time zone than the rest of the Ardent team back in the UK. And I'm not just sat in any place at the moment. This up here is what's known as a time ball. Now I'm not going to talk to you about that tonight, but we'll save that for another time. But I just thought it was quite appropriate that it's something that has been used historically to measure, or for ships, for maritime ships, to measure accurate time. So I'm going to talk to you a little bit more about how we deal with time zones, both in the real world and on our Ardent Training online theory courses. So yeah, listen on and hope you enjoy, and pop your comments below. Cheers!
Hey everybody, yes, I thought it was about time that we talked about time on a webinar. Sorry for the terrible pun. So I've made this webinar tonight just to get us a little bit more of an insight into time, how it came about, and also why it's important to us that we're aware specifically about time zones when we are out on the water, or even just planning our passages as well. So time zones have a big impact in that. Yeah, we're going to start off with a little bit of history, I guess, or how it all came about. So I pulled these couple of kind of definitions just from the internet, and I don't think there really is, if anybody could answer what is time without using, you know, something that we already use as a measurement of time. But it's a continued sequence of events from past to present, or to think about it in a kind of more basic sense, it's a measure to define the passage and progression of a day, but then is a day a time period anyway? So it starts to become all a bit kind of a thinking game, but hopefully it kind of gets the point across. Historically, we measured time by the motion of the sun and the stars and the moon across our skies. Now, of course, this wasn't actually everything moving across the sky. This was actually the Earth's rotation that was causing this to happen. And some of the earliest time measurements that have been recorded was just a stick in the ground measuring how the shadow changes through the day. Now, of course, this stick came on to become our sundial. And some of us may even have a sundial sitting outside our back door. Yeah, we still use these kind of early records for time measurement to this present day, which is pretty cool that they've lasted throughout all that time. Over time, things developed. And of course, the sundial is only useful if the sun is shining, which for those of us that are based in Scotland does not happen very much, sadly. And as knowledge and technology grew, so did the development of time measuring appliances. And so we went through stuff like candles, hourglasses, and then we came into our clocks, such as our pendulum clocks, our quartz clocks, until eventually all the very good, brainy, clever engineers developed the atomic clock. And that's what we use today to measure time. And they're still making it even more accurate. I'm not really sure if it needs to be more accurate. It kind of does the job, but that's our strive for excellence, that us as humans are always looking to kind of achieve more. Something that we like to do at Ardent Training too. So many, many years ago, the ancient Egyptians and the Babylonians they had kind of split their days and their nights into different parts. And what they'd done was they'd split their days into 10 parts and their nights into 12 parts. And the 2 additional parts that they had to generate what we think of as our 24 parts of the day were for their twilight, both in the morning and the evening. Their day parts were measured using the shadows that we've already discussed with the sundial or the stick in the ground. But their night parts were actually measured by the star configurations in the sky. And they were called decans. And each decan rose 40 minutes after the previous one. And so this helped them to be able to tell how far through the night they were, as each kind of decan or star configuration, or as we know it today, star constellation, rose through the sky. Now, they also had a prediction to the numbers of the base 60, which gives us our kind of 60 minutes in the hour. And we've kept this to this current day. But not only that, but it was also around that time that the circle got divided into 360 parts as well, which is, a key point of our navigation today, was a 360 degrees of the compass. But why the base 60? Well, 60, it's a really cool number. 60 is the smallest number divisible by the first 6 numbers, 1, 2, 3, 4, 5, and 6. But it's also divisible by 10, 12, 15, 20, and 30, which is a pretty amazing amount of numbers that it's divisible by. So that's why 60 was chosen as the base number, because so many other numbers would fit into it in an even way. And then we then kind of come on a little bit to an astronomer known as Hipparchus, and he, over 2,000 years ago, proposed dividing the day into 24, which was based on the 12 hours of daylight and the 12 hours of darkness experienced on the equinox. And the equinox was called as such because it was equal day and equal night. So that's kind of where the equi came from. And especially at that time, a lot of the world's population was kind of living closer to the equatorial regions. And so we did have more of a case of equal night and equal day. Despite this proposal, most cultures still varied the hour length based on daylight. And it wasn't actually until the first mechanical clocks that were produced in the 14th century that this dated motion, which we still keep to the current day, became commonplace. So yeah, we've kind of really only been following it for 600 years, but the idea has been around for over 2,000. And originally our hours were divided into longer parts for the ease of the public. But it wasn't until our clocks became mechanical that we were able to show this. And of course, there was no need for seconds either, because there was no accurate way to measure it. So it wasn't until, we're talking 500 years ago or so, that we started to have 60 parts in our hour, which we now know as minutes, and then obviously 60 parts in our minute, which we now know as seconds. But it's all still coming back to that base 60 that the Egyptians and Babylonians had kind of devised many years previous. How do we measure time now? As I said, we're now measuring time with our atomic clock and not by the Earth's rotation. So we're not counting the decans in the sky, the star calculations. We're not counting how many hours our shadow on the sun has moved around. And that's because our atomic clock is actually more accurate than the Earth's rotation. Additionally, the Earth's rotation is also slowing, and we correct this by adding in leap seconds. So you'll sometimes, on a slow news day, you'll maybe see that they've added a leap second on the news. So yeah, at the moment we add one about every 15 months or so, I think. And that slows our time back down to the Earth's rotational speed, because we still need to stay in tune with the sun.
I was quite excited to read that, because it means that we're also rushed off our feet. We're actually gaining time each day. So I think that's quite an exciting point that we're getting more time as the days go by. So that's comforting. Thanks, Stuart.
Or now. Yeah. So since the Earth has had a liquid ocean and a moon, then its rotation has actually been slowing thanks to tidal friction. So as the Earth's rotation slows, that means our days, essentially our 24-hour period as we know it, should be getting longer. And they are. But the changes are just so minuscule that they're too small for us to notice. So 4.5 billion years ago, one rotation of the Earth, so as we know, a day from sunrise to sunrise, took just 6 hours. And even 350 million years ago, one rotation was just 23 hours. So you can see that, yes, it is slowing, but, it's just something that we can't comprehend. And if we ignored all the other factors, I guess we could then say that in another 350 million years, in theory, it should take 25 hours. But I'm about to tell you how there's other factors at play too. So in saying that, today should be the longest day in the history of the Earth, and tomorrow longer still. However, that is not quite true. Since the end of the last ice age, the melting of the glaciers is causing the rotational speed of the Earth to speed up. And in recent times, as we are well aware, the melting of all these glaciers is accelerating. So that has actually escalated, causing this Earth's rotation to speed up. Not that we can measure it, but it is happening. And additionally, geological effects such as earthquakes, ocean currents, and winds can even change the Earth's rotational speed. So when did the longest day actually occur? So that was said to occur in 1912, and eventually tidal friction will once again overcome other factors, and the Earth's rotation will slow down again, and we will have a new longest day, and timekeepers will need to add leap seconds more often again. So yeah, that is a pretty cool fact. Although one thing that I always wonder about is how is that affecting, like with the moon? Because as we all know from our learning and courses, the moon is a driver of our tides. But the moon itself is actually moving away from the Earth. And the speed that the moon, this is me going off on a tangent here, so just bear with me. The speed that the moon is moving away from the Earth is equal to the speed that your fingernails grow at. So the distance your fingernail grows at is how fast the moon is moving away from the Earth. So that's another random fact for you. Back onto time, though. So how do we keep time? What do we call it, etc.? So what is universal time? Back when the railways were coming into being, clocks were commonplace, and every country set their clock to their solar noon. That was when the sun was at its highest point in the sky. And so for us in the UK, it was when the sun was due south at our highest point. And this was adequate enough for us. Our clocks were set to noon at the middle of the day when the sun's at its highest. And that was adequate enough until the railways came along. At that point, travel over a long distance was fast enough to necessitate the resetting of the train's clock. Because as the train got somewhere else in the country, it was already noon there when the train was supposed to be departing somewhere else at noon. So because of that, we, in the UK, we created GMT, which is Greenwich Mean Time. And so all the clocks around the country were set to GMT, and a radio telegraph signal was sent out to synchronize the clocks. And I even think at one stage, someone would jump on a train from London with their timepiece. They wouldn't have a watch like this, but they'd set their time. And then off they'd go on the train, and they'd get off at the next station, and they'd set the new clock, or they'd set the station clock to their time. And that was also how they helped keep it as well. Now, again, going off on another tangent, one of the other reasons that they needed to have a common place for time was, and I think it was in Cardiff, but I could be mistaken, but someone was asked to turn up at the local court for a hearing for potentially a crime that they had committed. And they were told to turn up at high noon. So they'd set their clock in Cardiff to high noon in London at Greenwich. And that had come and passed. Whereas actually high noon, where the sun is at this highest point in the sky in Cardiff, was about 20 minutes later. So this person turns up at the courtroom at 20 past high noon. And actually he was there at high noon, but not high noon is what they were meaning it for Greenwich. So again, it was another reason as to why we needed to have a common place of time. I always think that one's pretty cool because, yeah, high noon is different in London as it is in Tobermory, as it is wherever else you are in the UK. And then as it went on, other countries would have adopted the same procedure. They would have set their clocks to high noon somewhere in their country, and every other clock would have been the same. And in the 1880s, Standard Time came out. Lots of countries got together and kind of proposed to have a worldwide time, basically. Many countries had already adopted time based on the Greenwich meridian, and so they were already either setting their clocks or their time to so many hours after or so many hours before Greenwich. But as everybody got together, the proposal was to divide the world into 24 time zones, each of 15 degrees. 15 times 24 is 360. And in 1884, 2/3 of the world's nautical charts and maps used Greenwich as the prime meridian, so that made sense to accept and make Greenwich as the prime meridian. And so everywhere east or west of Greenwich would subtract hours accordingly. Now you'll see, I guess, when I get onto the charts and stuff, but one thing to be aware of is if we divide the world into 15 degrees, because Greenwich meridian is 0 degrees, it doesn't mean that a time zone goes from 0 to 15, 15 to 30, 30 to 45. It's actually 7.5 degrees each way. So the Greenwich mean time zone is from 7.5 degrees east to 7.5 degrees west. And so the next time zone east, which would be -1 in the nautical world, would be 7.5 degrees east to 22.5 degrees east. So it's just a little thing just to be aware of. Still 15 degrees segments, but not quite added up uniformly as from 0 to 15. The French, they didn't want to become part of this Greenwich Mean Time, and they had their own ideas on the base meridian, and they abstained from the vote in the late 1800s there. And at one time, I think the French, they wanted to have their base meridian as the most western tip of the Canary Islands. And I guess this was partly due to the way our nautical world worked at the time and how ships would sail across the Atlantic and the last bit of land they would see and that kind of thing. But eventually they did become a late adopter, and they officially came across to GMT timekeeping in 1911 and for navigational purposes in 1914. Up until then, they just had a correction in. And so Paris, I think, is 2 degrees east of Greenwich. So they had a correction of 9 minutes something that they had to take off to get back to Greenwich. And then later in the 1900s, we finally all made a bit more of an agreement, and our universal time became what it is today. So universal time code was UTC, which was equal to GMT, which is Greenwich Mean Time, which was equal to ZT, which is Zulu time. They all mean the same. They are all GMT or UT. And we base all our times on that just now. So if you ever see GMT, UT, ZT, UTC, they all mean the same thing. And then that brings us on to time zones. Now, technically, as I say, they divided the world into 24 time zones. But technically we have more, because some countries use half hours, some even by 15 minutes. And you'll quite often, you'll maybe go into a fancy building or a hotel, and sometimes even have them in airports, and you've got all these clock faces. And I think it's really cool to look at them and think, look at the time there. So when it's 9 o'clock in London, it's actually only 4 o'clock in New York, but it's already 10 o'clock in Paris, and it's already 5 o'clock in Tokyo. And another one in the time zone, there's a few islands to the east of New Zealand called the Chatham Islands, which are part of New Zealand. They're 45 minutes ahead of New Zealand. Don't ask me why 45 minutes and why not just the full hour. There's got to be some reason for it. But I don't know. But yeah, we do get slightly different time zones where we add in extra half hours or these 15 minutes or 45 minutes. But in theory, each zone should be split into chunks of 15 degrees. But the barriers change that whole countries can generally stay on the same time. Of course, some countries may even have different time zones throughout their countries. But as I mentioned earlier, each zone is 7.5 degrees either side of each 15-degree meridian. So you've got your first meridian of 0, so you've got a time zone UT of 7.5 degrees west to 7.5 degrees east. And then if we went further west, the next time zone would be either side of the 15-degree west meridian, and so we'd have 22.5 degrees west to 7.5 degrees west. If you went to 5 zones to the east, we would have 75 degrees east. And so that would go from 67.5 degrees east to 82.5 degrees east. And that would be UT minus 5. Now, something I should touch on, which we'll come back to anyway. In the nautical world, we always talk of time zones to the east as being UT minus and time zones to the west of UT plus. That is because we use the minus and plus as instruction of how to get back to Greenwich Mean Time. Whereas when we start looking at more land maps, it's the opposite way around. So be careful not to be confused about that. But because we're working in the nautical world, I'm going to keep referring to it as minus and plus, even though some of our diagrams might show otherwise. There's a cool picture here. I think that's from somewhere in Berlin. Some of you may have seen it. But yeah, it's pretty cool. It's like a world clock, and it tells you the time everywhere in the world. I've not been, although I have been to Berlin, but I've not seen that. But I assume that middle bit spins around. Then we start to look at the global map and time zones. And I could just look at these all day. I just get fascinated by it. I just think it's so cool. But I guess, I'm not going to go through every little time zone here. But if we look bang in the middle of this chart, this map, and we've kind of got UT 0, and we've got the UK's on that, Iceland, Portugal, the Canary Islands, and then most of Western Africa. And then as we go one zone to the east, we'd have UT minus 1, and we've got parts of Scandinavia, pretty much all of Central Europe, and then, most of Central Africa. And as we go across, you can see the color changes. The hash shaded ones, that's when someone is half an hour out. And you can see going across the country of Russia, it doesn't look like a country because it's split up into its different time zones. That's all. So you've got masses of different time zones across the one country. Whereas just below that, you've got a huge yellow splodge. That's China. China is all on one time zone, despite being such a big country. And then this one, I really, really like this one. I found it when I was last teaching an ocean course. And what it is it tells you how far out your time is from solar noon. So the darker the red means that your solar noon occurs much later in the day. And the darker the blue means your solar noon occurs much earlier in the day, so before 12 o'clock. And if it's just about white, your solar noon occurs around midday. So if you look at the UK, you can see down in the southeast where Greenwich and London are, it's pretty just about white. But the further west you go, the slightly darker red it gets. And as you look at this kind of picture in the whole, you'll see there's a lot more red than blue. And I guess that's just a human trait in that we want to maximize our daylight later in the day, to make the most of our evening light. And that's something that we try to do even more during certain times of the year, which I will get to. But yeah, there's quite a few kind of like anomalies in there. If you look down to the South America, right down, you've got Argentina. That's hugely red. So they're sitting on -3, but they're actually mostly in -4, -5. Yeah, it's obviously a reason that, they're going to have darker mornings, but much lighter nights. Come across to the other side, you've got where I am in New Zealand currently, and we're quite red, especially down to the southern of the two islands there. They're in the right time zone with being -12, but that would be 180 degrees east-west. So it should be from 172.5 degrees east to 172.5 degrees west would be that corridor. Well, where I am just now, it's 173 degrees east. So we're right at the western edge of that kind of zone, which makes high noon much later in the day. So actually, this week, noon for me, and I'm not even at the most eastern extremity of New Zealand, but noon for me is not actually until 1:45 almost in the afternoon. But part of that is because we're on daylight saving time, which I'll get to. Minus a plus, as I said, if you look closely at some of those charts, you may notice that to the east of Greenwich was plus and to the west of Greenwich was minus. Land and nautical time zones differ. Just be aware of that. We're working in the nautical world, and so we want to be aware that UT -5 means that we have to -5 hours to get back to UT. So if we're in the southern peninsula on our RYA world, it's UT -1. We -1 hour to get back to UT. Many nautical almanacs that we use for celestial or astro navigation around the world will produce the data in UT. So if you're on the other side of the world, so if I'm looking at it when I'm out on the water, then I need to be aware of what time zone I'm in and convert it back to UT. Now, there is something called arc time that can help with that, but that's something that you would do on our ocean course. Changing time zones. So I briefly touched on it there, but daylight savings time, something that many of us may look forward to. Some people don't like it, but DST, daylight savings time. And it was introduced in the early 19th century. I think the Germans started it first, sometime around the 1912, 13, 14 type thing, as it was noticed that many hours of daylight were lost during the summer months. And as such, summertime or daylight savings time came into being. Now, that's kind of been ever since for over 100 years now. But during World War II, in the UK, we adopted double time. So we went forward an hour in our winter and forward 2 hours in our summer to produce more daylight so that we could make a better production in the workforce. And then from 1968 to 1971 in the UK, it was always daylight savings time. So essentially, we went to UT -1. We were 1 hour ahead of UT. And ever since, there's always been discussions of having double time like we did during World War II. But there's a lot of things to be aware of and a lot of things to take into account, such as farming. That's what's providing all our food. So when do they need the daylight? Do they need the daylight in the morning? The school kids going to school in the dark or coming home in the dark. Transport, when's the biggest rush hour? Do we want it to be light during the rush hour, or do we want it to be light into the evenings? And then into the more modern thinking as well, we've got tourism as well. So that's all about kind of, if we have later nights, actually it's proven to encourage tourism. So there's that push as well. But if we make later nights, it's maybe not better for the farms or the school kids, and there'll just be an ongoing argument that will probably never be decided. Many countries do observe daylight savings time. As I say, I'm -13 just now because we're on daylight savings time. There's less need for DST at the equator because the distance from the sun's geographical position is less. And that's particularly well shown as in countries such as Brazil and Australia, where their northern areas that are closer to the equator stick to their standard zone time, whereas there are southern areas which are further away from the equator and so further away from the sun's geographical position, they do observe DST, and that's just up to each country. And I think there's a big thing in Europe over the past few years that the countries in Europe don't have to all have DST, whereas they used to have to, whereas now it's up to each country, although I think there's an ongoing argument about that. But it's important to think, what time zone are we on? Are we on UT, DST, UT -1? So for the UK, at the moment, you're on UT. In another 6 weeks or so, the clocks will spring forward, and they go forward 1 hour. So just your way to remember is the springtime. That means we'll then be on DST. We just refer to it as DST, but it is actually also UT -1. If you see LT for local time, then that would just be, UT -1 if it's summertime, or UT if it's winter time in the UK. So yes, both are our time zone and our local time. So it's just a one to think of. In the summer, our time zone is UT -1. It's just a different way of, whether you write DST or UT -1, doesn't matter. They're the same thing for the UK in the summer. These are just some cool things that I found. And time zones are for trains, not people, which is quite true. Why are we so fixated with time? How many of you have checked your watch as we look through this webinar type thing? Or like through the day, or to see how much is left in your day? We're very fixated by time and everything that we do. But actually, time was made for trains initially, and not for us. We existed as a civilization for century and millennia before we actually had time. Our time zones, as we've just been discussing, especially with daylight savings time, they actually put our bodies out of natural sync with the sun's daylight. Now, for some of us who are resident in very high latitudes, we only get so much sunlight through the day. But for those maybe closer to the tropics or equatorial regions, then you may find that your time zone is putting you out of sync with the sun's daylight. And another reason that countries change time zone is to stay on a time zone with a nearby country that they trade with. And it's less important now that the UK is not part of Europe, but there was always the chat of going on to UT -1 purely for a business sense as well. China, as I said, it's all in one time zone. But is it? So they did have different time zones, but when the current party came into power, which I think was the late 40s or early 50s, they tried to have one time zone to try and kind of unite the country. And it kind of does. So they're on Beijing, and Beijing is roughly on their solar noon. But actually, many outer reaches of China actually just hold their own time, especially those in the outer villages and stuff like that, which is something I thought was pretty cool. We could have like our own time up in Tobimori time, TT. As a result, it means that the biggest land border difference of time, so stepping from one bit of land to other, you can change by 3.5 hours by going from China to Afghanistan. Not 100% sure if that border is actually crossable, but right next to it, you've got China to Pakistan, which I think is at least 3 hours as well, which is a pretty amazing difference just by stepping across the border. Of course, you can do it the opposite way. You can fly across the international date line, and you could have 2 Saturday nights out in a row if you planned it right. The International Space Station follows Universal Time, UT. Solo sailors around the world, they tend to follow UT or UT -1, specifically the solo ones, because they don't need to stay in a rhythm of this is when we have breakfast, this is when we have dinner. But they stay on UT or UT -1 because that is the time that their shore base works on. And that way they have, they're on the same time, they're talking the same time. And at the end of the day, by the time they get around the Southern Ocean, they come back to the same time as well. Antarctica, so a cool one, the US station called McMurdo down in Antarctica. It's on New Zealand time. But why? Why would it be? Because most stations would generally stay on their own country's time zone. Well, that's because all flights in and out of that kind of area of stations, where there's a few of them together, they all come from Christchurch, which is in New Zealand. So they may as well stick on the same time that everybody comes in and out from. I think there's over 1,000 people down there on the US station, which is quite a lot. Whereas the North Pole and other research stations, they tend to use the same time as their respective countries. Again, it's kind of like the shore contact for the round the world sailor. At sea, this is kind of a bit more thinking along our lines for us. And again, it kind of goes back to that big question right at the start. Does time really matter? For those of us who kind of spent time when we're sailing offshore, and suddenly we stop getting messages and emails on our phones and stuff, it's kind of like, well, does time really matter? You know, the only time that we're focused on is when is the end of our watch, or when do we have to be back on watch? But actually, our time could be governed by the sun going up and down and high noon, so that we can get our meridian passage celestial sight of the sun and find our latitude for the day. But it does open up the questions of when do you change your clocks at sea? What about your watch systems, etc.? And that doesn't even have to be for an ocean crossing. Just crossing the channel, you're going to have to change your clock at some stage. So when do you do it? So it's just all these things to think about, and you have to be aware of that it is changing, when to do it, that kind of thing. One thing to get to be careful of is our phones, as you are probably well aware of. You've got settings on them to take them off, but your phones will generally automatically update. And as I found, even when they're on airplane mode, depending on the settings, they can actually update their time as well, which means if you're using your phone for an alarm, you could be late for your watch. I've only ever been late for a watch twice, and both times it was because my phone didn't wake me up in time, because my phone had went back an hour, and so I was supposed to wake up for my next watch, and I didn't. So I think that was going into, I think both times was sailing into Iceland. Iceland are on UT all year round, and so my phone was already on UK or whatever, but it went back an hour onto UT in Iceland during the summer, and so so my phone was an hour slow, and someone comes to wake me up. So I'm like, oh, what's happening? Why are you waking me up? What's happened? It's like, oh, you're actually 40 minutes late for your watch. It's like, oops. Just be careful of that one. Yeah, watch systems. When you change if you're sailing through different time zones, when are you going to change? How's it going to affect your watch system? You've got to make it fair. It's unfair if the same on watch is always on when you lose an hour or gain an hour. And how does that affect your timing of meals plans? Everybody will have different reasons for doing it. I'm sure some of us will share them later on. But yeah, it's just something to think about, and how you go about changing times. For daylight savings time, it happens at 2:00 in the morning to be as minimal as possible. But there's still a lot of, consequences of that, such as 13 hours for your night shift workers and various other things. Changing DST does add its problems as well. And your logbook, do you note down your time zone in your logbook? If you're changing your time zone, you need to remember and note this change. But it's always good to change at a recognized time, so that if you ever have to go back, you're not getting confused as, oh, I don't know if that was 1900 yesterday's time or 1900 today's time. It's important to be aware of that. If we're just going out sailing and we're using local time for a coastal passage, it's not so important. But as soon as you start sailing across the channel or sailing between countries, you need to start adding your time zone into your logbook. And that's why it's so important that when we're dealing with some of the questions in our courses, for those that do our online courses, that we're so picky about it being UT or DST, etc., because it's so important. And yeah, speak of the devil, our RYA courses, it will always be clear in the almanacs what you're dealing with. And on page 2 of our RYA training almanac, it says this: the time zone for Northern Territories is Universal Time, Zone 0. The Northern Territories also has Daylight Savings Time, DST, as noted in the timetables within this training almanac. The Southern Peninsula on the southern section of the chart has a minus 0100 time zone. That means to convert Southern Peninsula to UT, you minus 1 hour. It also has its own DST as shown in the time zones, and the Neptune Islands have the same time zone and DST as the Southern Peninsula. So the information's all there. It's just very small, and it's just a key learning point to make sure you always read these key bits of information so that you know what time zone you are and how to get between the time zones. But in the nautical world, -1 means you minus 1 hour to go back to UT. That gives our training time zones this. So the Northern Territories are UT, so 2030 UT. But if it was daylight savings time, they would become UT -1, and it would be 2130 DST. And Southern Peninsula, UT -1, as we've just discussed with the Neptune Islands, again would be 2130 SPT. And if they went into daylight savings time, UT -2 would be 2230 SPDST, assuming that we're all just focused on what time everybody would be at a given time. So yeah, just a good learning point for those on the time zone of our courses there to try and get to understand it. And so the -2 there, 2230, -2 hours to get back to UT 2030. Timetables, they're super clear. This one here for Victoria says time zone UT. For summertime, add 1 hour in non-shaded areas. Okay, that's saying to get to the daylight savings time, you have to add your 1 hour in the non-shaded areas. So yeah, if we need to change times in our timetables, it will be clearly noted. So yeah, just beware of that. So the Victoria here, we stick to UT in February, but if we're in April, it would be UT -1, and so we'd have to add an hour to our tide times. Colville, the time zone, again, is very clear. It's -0100. So looking at the picture here in November, that means the times there are UT -1, but it also says for summertime to add non-shaded areas. So if I was in September at Colville, I'm going to have to add an hour to that time to get it into the UT -2, which is the DST observed at Colville. So yeah, it's super clear. It tells us what to do in the tide tables, and yeah, hopefully that kind of just irons it all out for us. Secondary ports as well. Super key that we're aware of this. The data for secondary port time differences is given for the almanac time of that port. Now, the almanac time for all the tide tables, as we've seen, is given in either UT or UT -1. So Colville, which is the one for Dawson Harbour here, as we've just seen, is given as time zone -0100, so UT -1. But if it's summertime and you need to convert to DST, then you need to do that after you've worked out the secondary port time differences. That's because these constants that are given to us, are based on the time that is within the almanac, the standard time for that port, which would be UT or UT -1. So secondary ports, do your DST after you've worked out time differences. And finally, everyday life sailing. I've mentioned the channel a couple of times. It's the key one for a lot of us based here in the UK. So we've got France and the Channel Islands here. So that's the easiest place that we can start to get messed up a little bit. So yeah, you just got to be super careful when you're sailing across the Channel, when you're going into the Channel Islands, when you're going from the Channel Islands to France, what is happening? What is the time zone? And that kind of goes for all the areas you're looking in, such as your tidal heights. What is the time zone that they're given in? Your tidal streams. What is your reference port for your tidal streams? What's your standard port? Where is that? And you're going to have different reference ports and standard ports for the different harbours that you may start and finish the day in as well. So yeah, you just got to be super careful on your time zones when you're sailing in and around these areas. Check your local time zone, as I say, wherever you are in the world, not just the Channel Islands and the English Channel. And yeah, do it for your local tidal height, your standard port, your reference port. Just double check and make sure. This picture here, I pulled up, and it was just to, because it was just telling me the time in each capital country of the world when I pulled this off. But the interesting thing I found it, and I just wanted to touch on it as a little tangent, was there's only 5 places in the world that are currently serving daylight savings time. New Zealand's one of them. I think there's parts of Australia that are doing it. And then I think Paraguay is another, but I'd have to double check what the last 2 were. But it's probably going to be someone like maybe Argentina or southern Brazil and another country down at the other end of South America, potentially parts of Chile. Oh, and the other one that I found really weird, and I'm not 100% sure if this is true, was Morocco is currently on some sort of daylight savings time. And for a month, it says that they come off it between March and April, and then they go back on it again. So if anyone's ever been and can confirm that, then that would be really interesting to know. But it sounds like they have some sort of weird winter daylight savings time. Other areas to note, getting back to the important stuff, weather forecasts. We're all going to look at weather forecasts, but when were they issued? What time zone were they in? And has it pre-calculated the time zone for you? So this picture, I looked at it last night at my time, Monday the 12th, 1900. So that was Sunday, 1800 in the UK. So that's what was the forecast. But there's nothing to tell me what the time zone is on there. Now, some of them do show it, some of them don't. So just be super careful. But for this one, there's no time zone. But actually, I know, because I checked it at the time, that it was already on UT -13. But I'd have to note that down to be aware of it. Also, your departure and arrival times and ports. What's the local time in the port? How's that going to affect your, your time zones? Port opening times, how are they described? And what time zone are they in? So you might open up your almanac and you'll be like, it says that this port is open from 0800 to 2000. But what time zone is that? So be sure to check these things. Radio announcement times as well is a key one. I know many years ago, the weather bulletin forecasts were always given at whatever time it was. So my local time on the Clyde, it was given at 0710 UT, which meant in the summer, it was actually 0810 because we were observing DST, which meant we were UT -1. But I think over the years, they might have changed this and they actually changed the time, but maybe someone else can confirm that for me. But either way, you want to double check, especially if you're sailing in unfamiliar waters and you're looking to listen to a forecast. You don't want to be an hour out. So yeah, all these different areas to be aware of. And I'm sure someone's going to share a story with us as well of when they got time wrong. That's all we have time for this evening. This, like many of our subjects and masterclasses and various areas that we talk about, and we could be here all night, all morning, all afternoon, whatever time zone it is you're in. But thanks for giving me your time. I'm pleased to have spent my time with you and giving you an intro to time. And I'll just allow Charlie Triggs to finish up before we'll answer any questions.
Thanks very much, Stuart. That was brilliant. Really interesting. Always learn something new from your webinars. Looking through the chat. We haven't had many questions, but we've had a few interesting things. So Alice keeps their clocks on GMT +1 year round, so that there's an extra hour of daylight in the evening year round, which is quite a nice take on things. Bill has put an interesting comment in that naval or military local time is referenced alphabetically. So Zulu is GMT, or UTC is Zulu time, and then it goes up. So if Alpha time, Bravo time, Charlie time is UTC +1, +2, +3, right the way through the alphabet. But that's quite an interesting fact. So thank you, Bill, for sharing that. Question that's come in from Alice is just checking that can secondary and primary ports be in different time zones? And I'm sure Stuart will correct me if I'm wrong, but I think the answer to that is no. And that's because the secondary ports are effectively differences from the primary ports. So you've got your primary ports and your secondary ports. To calculate those, you're just applying differences. So they have to be in the same time zone. Thanks for joining us. And don't forget to follow us on Facebook, Instagram, LinkedIn, and YouTube, where things like this get published fairly regularly.
Cool. Awesome. Thanks, everybody.
Okay, Charlie, when the house bears about 270 degrees.
Information to work out our distance from the lighthouse and use that.
We might be perfectly on track, but if we're not on time...
Just have a look. I've got my phone here at the effects it has on our steering compass.
Our echo sound is working. We can find a contour and follow it nicely into port.
Our left hand is pointing towards the centre of the lobe.